All right, so for part B, this one a little bit different than we've seen in some of the other problems. It's asking us to find the second derivative in terms of x and y, and then to describe the region in the xy plane in which all the solution curves to the differential equation are concave up. So how do we know when something's concave up? Second derivative is positive, right? So our second derivative is positive. So first we're going to have to figure out where our second derivative is in terms of x and y. Then we need to figure out when is that second derivative positive. So our equation for this one was dy dx equals 1/2 x plus y minus 1. So our first step here is to find the second derivative. So we're doing this derivative in terms of y. So basically we're just doing the derivative we're doing the derivative in terms of x. So we're doing the derivative of each side in terms of x. This becomes the second derivative of y with respect to x. Over here, derivative of 1/2 x is just 1/2. Derivative of y, just 1 dy dx. And then derivative of negative 1 would be 0. But remember in the directions here, it says we want to find the second derivative in terms of x and y. That means this dy dx doesn't cut it. We can only have this in terms of x and y. Can't have anything else in there. I mean, we can have numbers, but this dy dx not going to be acceptable. So we already know what dy dx is. We just had it written right here. Dy dx is 1/2 x plus y minus 1. So we can replace this dy dx with what it is in terms of x and y. So our second derivative of y with respect to x is going to be 1/2 plus this whole thing. So 1/2 x plus y minus 1. And we can combine like terms there. The 1/2 minus 1. We end up with 1/2 x plus y minus 1/2. So that's our second derivative. That part is worth 2 points. First one doing the original derivative, second one substituting that in and simplifying. So we get a total of 2 points for that part of the problem, but we're not done. You need to be careful with AP questions because a lot of times you'll get something done, you get an answer and you think you're done, but there was maybe a second part to that. So it says describe the region in the xy plane where the solution curves to the differential equation are concave up. Well, normally to figure out where it's concave up, we do like a number line, put the points on the number line where the second derivative is 0, and check in between and figure out when the second derivative is positive. It doesn't work that way when we've got x and y in our equation. If it was just x in our equation, we could do it that way. But having x and y both in there makes it a little more complicated. But we do know, in order to be concave up, the second derivative has to be greater than 0. So that's what we're going to do, is we're going to set this second derivative greater than 0. And we can solve this for y. We get y is greater than negative 1/2 x plus 1/2. So basically, if we were thinking about this, the line y equals negative 1/2 x plus 1/2, if we looked at that graph of the line, everything above that line would be concave up. So we just want to go ahead and finish our answer here. The graph is concave up when y is greater than negative 1/2 x plus 1/2. Right, so that part of the problem is worth 1 point. You're explaining where it's concave up is worth 1 point.